Hey, hello and welcome to today's GFG problem of the day. Number of sub-arrays with maximum values in given range. So let's see what the problem has to say. Given an array of n elements and L and R, print the number of sub-arrays such that the value of the maximum array element in that sub-array is at least L and at most R. So let's see through an example, right? So here the example is given as uh, yeah 201130. Okay, so what they are saying that you have to count the number of sub arrays such that in that sub array the maximum element should be greater than L and at least greater than or equal to, at least means greater than equal to L or less than equal to R, less than equal to R, right? So let's see through this example what can be the sub arrays, right? So first sub array can be this, right? 2. So it is, what is L here? L, for example, L is 1 and R is 10. So this particular element is satisfying this condition, right? L is 2 is greater than equal to 1, right? And R and definitely it is less than 10, right? So this can be one sub array. Then second can be what? 2 comma 0, right? In this sub array again the maximum element is adhering to this condition, greater than equal to L and less than equal to R. Then again, right, here it will stop because it is, this element is greater than R, right? This element is greater than R. Then the sub array needs to be contiguous elements, right? The sub array needs to be contiguous elements. So next element will go to the next element, again it is adhering to this condition L and R, right? So one sub array can be this. Again here 3 comma 0, right? So next sub array can be this, right? So yeah, in this way there can be 4 sub arrays. So let's see one more example. Let's slightly modify this example itself. Let's bring into 204. We have added 4, right? So again, if we go here, one sub array will be 2, right? Then next sub array will be 2 and 0, right? Then next sub array can be 4, right? This, when we go 4 is also adhering to greater than equal to L and less than R, right? One sub array can be 0 4, right? 0 4, right? And one sub array can be 2 0 4, this way 2 0 4. And again here it will be same 3 comma 0 and 3. Sorry, yeah, first 3 will come, right? And then 3 comma 0. So 1 2 3 4 5 6 7. There can be 7 sub arrays in this particular example, right? 0 cannot be individual sub array because it is not adhering to this condition, right? It is not following the condition. It is less than L. So it can be part of the sub array, right? It can be part of the sub array because the condition given is the value of the maximum array element in that sub array, right? So it can be part of sub array, but it cannot be an individual sub array, right? Yeah. So if you see, right, whenever there's sub array, then there are chances, right? There are chances of sliding window technique. So I will say it's uh, yeah, it's an example of sliding window technique. So let's see, right, what we can do, right? What we can do. Let's take an example over here. Let's take the same example, right? 2 0 4, then 11 and 3 comma 0. So what we'll do first? What we'll do is we'll take a pointer WE, right? This is window end, and WS, window start, right? Window start. And we'll iterate, and the counter will be this WE. Okay. So we'll check, right? We'll check here whether this element, if it is greater than equal to L, right? L equal to 1 and R equal to 10. Yeah, and if it is less than equal to R, right? So this matches, right? So what we'll do when this matches, right? So we'll take another variable, sub array size, right? Sub array size will take. So if, right, here air of WE, right? This condition, air of WE greater than equal to L, this is a condition, right? Then what we'll do, we will sub array size equal to WE minus WS plus 1, right? So both WE and WS are pointing to the same element, right? So subarray size will be here. What it will be? Subarray size will be WE, 0 minus 0 plus 1. So it will be 1, right? And then we'll take definitely this answer variable, right? And we'll add, right? So we got our first subarray, right? We want to count the number of subarrays. So we got a first subarray size is 1, right? And then we come to the next element, we'll increment WE, right? We'll increment WE here, right? WS will be same, there only, pointing to 2, right? So WE is now pointing to 0. So it is not satisfying this condition, right? It is not satisfying this condition. Neither it is satisfying this condition. We'll come to this condition later on, right? So subarray size will be same, 1, right? 1. So what we are adding here, 2 comma 0, right? This subarray size we are 1 means, right, this subarray we have included, right? We have considered this subarray. Then we'll come here, 4. WE will be incremented to 4, right? W will be incremented to 4. Now, yes, this satisfies. It is greater than 1 and less than equal to 10, right? Right? So, what we'll do? Subarray size. Now, WE. What is WE? WE is at 2, second position. Second position. And WS is at 0. So, right? So, 2 minus 0 plus 1 will give us 3, right? So, subarray size will be 3 now. Here, right? This is a subarray. Subarray size will be 3. So subarray, when we say, right, subarray size. So how many subarrays? This basically this means how many subarrays, right? How many subarrays? So one will be 4, right? One will be 4. One will be 0, 4, right? And one will be 2, 0, 4. Okay. So here there will be 3 subarrays over here, right? So here WE minus W, it is satisfying that condition, right? So it will be 3. So we added count 3 here to the answer. So we got 5 till now, right? Answer equal to 5, right? 1, 2, 3, 4, 5. And then we'll come to this. W will be incremented. Now this is greater. This does not satisfy. This is greater than R, right? So we'll come over here. So here the subarray, like it cannot be, the subarray cannot be proceeded further. So subarray will be 0 now, right? 0. And WS till now was pointing here. So definitely the chances are that the new subarray can start from the next element. Here, from here, it cannot start. So chances are that the new subarray can be started from next element, right? So we are doing WS equal to WE plus 1, right? 3. Okay. Now again we come here. Okay, to 3. WE is also pointing here. WS is also pointing here, right? So now we are checking. Yes, this element adheres to this condition, right? Follows the condition. So now WE and WS both are 0, 1, 2, 3, 4. Fourth position, right? 4 minus 4 plus 1 will give us 1 only, right? Because only one size subarray, right? So we added, right, answer plus equal to subarray, right? And then we come to this element. It does not follow this condition, does not also satisfy this condition, but subarray size will be same, right? 1, right? So here this 1 indicates 3 comma 0. We have included this, right? We have included this 3 comma 0. So now answer finally goes to 7, right? So we are returning 7. I hope you have got the solution, the pseudo code. Let's walk through. The code is same, right? The code is same what I have explained. Okay, so let's submit. Okay, the solution is accepted. I hope you have got the solution. We are also adhering to the time complexity and space complexity. We are not taking any extra space, right? O of 1, right? We are not taking any extra space, and we are adhering to time complexity, O of n, right? Here, O of n. Yes. So thanks for watching. Please like the video and subscribe to my channel. Thank you.